Okay, Bismillah Rahman Rahim. In the previous phase of the lecture, I have discussed about uh, the the definition of the measurement and instrumentation, and then we have explained some terminologies of this course and the block diagram of the measurement system, and I have given you the example of the fuel indication in the vehicles. Okay, and then the calibration process, and then the test instrumentation phase after the calibration, and few terms regarding this subject, that is the transducer, the electronic transducer, sensor, and actuator. Okay, now why we are doing the measurement? What is the purpose of doing the measurement, and what is the role of the measurement in our daily life? So it's a very simple question, and all of you will observe its importance and its significance in our daily life. That in any industries, for improving the quality of the product and efficiency of the production, and to maintain a proper operation in any industry, it is very mandatory. Especially, for example, if I take the example of the weight, so in any product, if there is no process of the measurement regarding the weight, so it will disturb the quality and the quantity and the efficiency and the whole operation of the industry, because in some product it will have high weight, and in some it will have the low weight. So on the receiving end of the consumer, it will also cause a problem for this industry, because they will complaining regarding the weight issue uh, of that product which they have purchased. So this is the one example. So similarly, if I take the example of the pharmaceutical industry, so for any uh, pills, any tablet, uh, there is a composition of many chemicals. So if you can observe it on any of the the manual which is placed inside any tablet, that what composition is involved in manufacturing that tablet. So if this composition is not maintained, so it will be hazardous for the user. So, for example, if the anesthetic portion high as compared to other antibiotic or any other term, any other chemical, so it will cause a very dangerous situation or a hazardous situation for uh, the patient. So it may cause death for of that patient. So this is the measurement is mandatory in every industry, especially in the pharmaceutical. Okay, so this was all about the role and the purpose of the measurement. Okay, so now the generalized measuring system, this is the input system. Okay, so it will give the physical quantity which is need to be measured. So sensing element. Okay, the sensor will sense uh, that input quantity, that physical quantity, and it a signal conditioning element. Okay, we will give a condition for this input signal, and it will process, and then it will present it. So let's again give the example of the fuel tank. Okay, so input is the fuel. Okay, and the fuel level, the level tank will sense it, and the condition. Yeah, you may observe, for example, for CNG, okay, compressed natural gas, we have uh, four LEDs indicator. The below one is the red color, which shows the reserve, okay, reserve level, and these three are in yellow color or the light green color. Okay, so in condition we have given the condition that, for example, if it is uh, below 1 kg, for example, so indicate this by this led, by red color, okay, and if it is between 1 kg and 2 kg, so indicate by this led. So these are the conditions, okay. If it is between 2 and 4, for example, so indicate by this, and if it is greater than 4, indicate by this led. So these are the conditions, okay. These will be processed, and these led are actually the presentation, and we will have the output in this format, okay. So this is the example of the generalized measuring system by a block diagram. Now the type of the instruments, some are the active instruments and some are the passive. So those instruments which are working in the absence of any voltage source or the power source. So these are the active instruments. Okay, sorry, these are the passive. And if any external power source is involved, so these are then the active instruments. Okay, so uh, active instruments, the quantity being measured simply modules the magnitude of some external power source, and the instrument output is entirely produced by the quantity being measured. Difference between the active and the passive instrument is the level of the measurement resolution that can be obtained. Okay, so for the example of the active instrument are this float type petrol tank level indicator. Okay, this is the floater. These are the fuel tank. Okay, and these are the needle or the pyout. Okay, so and this is the resistance. So by uh, the level of up and down, the pyout will select the corresponding resistance, okay, and it will give the output voltage by selecting the appropriate resistance, okay. When the level is high, so the resistance will be high, so the voltage will be high, okay. And when the level is low, so it will select the low resistance, and we will give the low voltage. So this resistance is actually uh, powered by an external source, okay. So by this way a current is flowing by this way, okay. The loop is completing by this way. So this is the example of the active instrument. Now, okay, so the change in the petrol level moves a potentiometer arm, and the output signal consists of a proportion of the external voltage source applied across the two ends of the potentiometer. The energy in the output signal comes from the external power source. The primary transducer float system is merely modulating the value of the voltage from this external power source. Okay, now this is example of the passive instrument, the pressure measuring device, okay. So there is no need of any external power source, rather this piston will indicate the pressure this on this scale. When the pressure is high, so it will indicate the level by over here, okay. And when the pressure is low, so it will indicate over here. So this is the high value, this is the low value, so the scale will be from 0 to high values, okay. For example 10 or 50 or anything. So there is no need of any power, external power source for in measuring this quantity, okay. The pressure of the fluid is translated into the movement of the pointer against scale. The energy expended in moving the pointer is derived entirely from the change in pressure measured. There are no other energy input to the system. Okay, now these are the instrument types, the analog and the digital. Okay, so an analog instrument gives an output that varies continuously as the quantity being measured. So the deflecting type of gadgets are the analog. So the analog voltmeter, analog. So you may be familiar with these instruments. So it will give you the output at any time, uh, continuously. So these are the analog instrument. And compared to analog, we have now the digital instruments. So the digital instruments has an output that varies in discrete steps and only have a finite value of number of values. So revolution counter, okay, these are the output of the digital instrument. So you can see that it gives us the integral value, not the value at any time. So the steps of the values has been selected. So these are actually the digital values. Okay, so these are the finite values. Okay, calibration, we have discussed the calibration process. So calibration consists of comparing the output of the instrument or the sensor under test against the output of an instrument of known accuracy or higher accuracy. When the same input, the measured quantity is applied to both instruments. So the procedure is carried out for a range of inputs covering the whole measurement range of the instrument or the sensor. Ensure that the measuring accuracy of all the instrument and the sensor used in the measurement system is known over the whole measurement range, provided that the calibrated instrument and the sensor are used in environmental conditions that are the same as those under which they were calibrated. So I've already given the example of the thermometer, that you have to calibrate the thermometer by comparing it with the known value having the high accuracy. So and after that we have to pass the calibrated instrument through the test phase for its authentication or verification. Okay, so calibration involves a comparison of the instrument with either the primary standard, the secondary standard, and the known input. So the example is the standard weight measurement facility, for example NIST. Okay, and another weighting instrument of the higher accuracy, the MAST standard. So as you all know that the for different physical quantities, a standard has been defined and it is placed in different labs in different countries. So the length is for example the length is placed in some in one country of the Europe. I forgot the name. Maybe it is UK or the France. So the the weight is placed in some other country, and it is placed in such a way that the optimum it is placed in the optimum condition that it may not be disturbed by the environmental effect. So as you know that the length can be affected by the environmental by the surrounding temperature. In summer or in hot conditions, the length, the metallic length expand, and in cold conditions the metallic length is contracted. So if it is disturbed by the environmental temperature, so and the other countries which are intended to calibrate it to or to measure their own foot ruder scale or rod with that standard, so it will be full of error. It will be not as standardized as it is, because it is already affected by the environmental conditions. So for this purpose, these standard has been placed in optimum condition that may not be disturbed by the environmental temperature, neither in cold in winter or nor in December. Okay, so these are all about the calibration of any instrument with the standard. Okay, so analog and digital. Okay, the passive, uh, the petrol tank, the active, the types of the instruments. Okay, the block diagram of generalized measurement system, and the role and the purpose of the measurement system, and some terminologies. Okay, so that was all about the first lecture, and if you have any question, you can ask in the WhatsApp group. So thank you.